next and final experiment we have now is basically the transdermal patch making and checking of its activity. So, transdermal patch. So, there are various ways to deliver the drug. So, in this case of propranolol hydrochloride, it is transdermal patch. Okay. So, that is a drug delivery system, so defined self-contained a discrete dosage is keep on being applied over a period of through skin releases in a controlled rate of the systemic circulation. Okay. So, the rate of movements across the layer depends on its concentration in vehicle, aqueous solubility as well as the organic and water partition coefficient and in the vehicle. Substances both in aqueous and lipid solubility characteristics are very good candidates for diffusion through the epidermis as well as the dermis. And what is the pros and cons of transdermal patch? There is no systemic first pass metabolism, controlled release of over extended period of time, easily terminable means that systemic as well as the topical drug delivery may be obtained, less frequent administration because you are putting a patch on your shoulder. So, less frequent administration, and patient also if you are going to inject it, people may not very much come forward, but if you are going to put a patch on a shoulder, they may not mind too much. So, that is advantage of compliance from the patients. And disadvantages obviously because of you are having a patch on your skin, irritation, and the dose because of what kind of incorporation you are doing it, and lag time of absorption and the onset of action in variation in the absorption rate also gets it, and failure of aggressiveness and high manufacturing cost is the another cons of the transdermal patch. Propranalol, how do you make after making a patch, how do you find out that it is dispatched properly? So, 100 milligram of propranolol was weighed and transferred to the 100 ml standard flask, and it was made up to the 7.4 phosphate buffer. From the above solution, 10 ml of was pipetted out in a 100 ml flask and made the volume up to the phosphate buffer up to 100, 7.4 pH with the buffer solution. And from this 2, 4, 6, 8 and 10 ml of above solution were taken as separate 100 ml standard flask to represent 2 micrograms, 4 micrograms, 6, 8 and 10 of drug made to the volume of 100 with a 7.4 pH buffer. All the absorbance in the cell at 290, the graph is plotted against the concentration on x axis and absorbance on the y axis. You found out what is the standard concentration you found for the 2 microgram, 6 microgram, 8 and 10. How do you prepare the transdermal patch? So, the weight quantity of a drug was dissolved in dichloromethane and methanol. So, that is required in a beaker. The polymer is weighed in the dissolved in dichloromethane and of course, methanol in a another 50 ml beaker. Polymer solution was poured into the drug solution and stirred well with the magnetic stirrer for about an hour. And to this 0.5 ml of polyethylene glycol and 0.5 ml of DMSO, which acts as a permeation enhancers, were added and mixed well. Then the solution was transferred to a glass petri dish, and while pouring into the petri dish, you need to take a precaution so it does not form the air bubble. Okay. So, after it takes about overnight to form the patch, and how do you now find out the estimation of concentration? From the patch you formed, you cut out the small portion by 2 centimeter by 2 centimeter and dissolved in 100 ml of phosphate buffer and vigorously shake for about 30 minutes, and whole solution was ultrasonically for 15 minutes. After filtration, the drug was estimated spectrophotometrically at wavelength of 290 nanometer, determine the drug content, because since you have already taken the standard values and from the absorbance you found from by the extraction from the patch, you will come to know what is the concentration of the release of the solution. So, you can take 1 square meters or 2 square meter patches was cut, depending on the, in this case they cut for 1 square meter, there has been 1 by 1 centimeter was cut, and it was opened as a tube which was tied to the cellophane paper, and the tube was placed in a beaker containing the transdermal phosphate buffer. So, because we want to find out how it get released over a period of time. Okay. So, now you put it in a tube and invert it, and you put it in a beaker containing the water solution. Okay. So, the beaker was then placed in a magnetic stirrer at 50 rpm, rounds per minute, and temperature maintained at 37 degrees Celsius. And the sample was withdrawn in every 15 minutes for an hour and followed by every 30 minutes in the second hour. Okay. So, you measure how the patch is releasing into the aqueous solution, how much it is going to get released, and the samples were diluted 10 times with the phosphate buffer, and the absorption was measured at 290 nanometer to the percentage of drug released by the UV data. So, you can find out that from drug is getting slowly released from 20 minutes to about 1 hour, about 2 hours, is about 70% of the drugs getting released from the patches actually. Okay. This one will be followed by the experiment which is done by both Hari and Ankur. It will be displayed and you go through the experiment. For all the things we have already uploaded in the, I have already uploaded in the Google Classroom all the references along with the supporting information. So, by this weekend or by beginning of next week, we will upload all the questions also, and I sincerely request you to go through every article, supporting information completely. That will help you to answer the questions, the model questions you are given, you will be given, and by without going through the supporting information and solving the questions will be difficult. So, please go through the entire supporting information properly. Okay. And followed by this, the video will be played and it will be concluded.
"50 milliliters of dichloromethane was taken in a beaker. Weigh 750 milligrams of HPMC and added slowly to the DCM with vigorous stirring. Weigh 150 milligrams of drug Propranalol and dissolve it in 1 milliliter of dichloromethane and methanol. polymer solution was poured into drug solution and stirred well with magnetic stirrer for about 1 hour. Zero point 0.5 milliliters polyethylene glycol was added to the polymer drug mixture. 0.5 milliliters DMSO was then added to the polymer drug mixture. The transparent solution is poured into glass petri dish and kept undisturbed overnight to get the transdermal patch. Concentrations of 2, 4, 6, 8, and 10 micrograms of drug propranolol is made with phosphate buffer pH 7.4, and absorbance is measured at 290 nanometers. A calibration graph is plotted taking concentration on x-axis and absorbance on y-axis. 1 square centimeter patch was cut and placed in the open-ended tube. One end of the tube is tied with dialysis membrane. The tube was placed in a beaker containing 200 milliliters of phosphate buffer with pH 7.4. The beaker was then placed on a magnetic stirrer at 50 rpm, and the temperature is maintained at 37 degrees Celsius. The sample was withdrawn every 15 minutes for 1 hour, followed by every 30 minutes for a second hour. The absorbance of the sample was measured at 290 nanometers and the percentage drug release was calculated from the data.